All right. Well, hello, Honors Algebra 2. Welcome to the second lesson in this Statistics and Probability unit. Today we're going to be talking about data displays, which is our way of displaying all this data that we talked about collecting in the previous lesson. So we're going to talk about four primary data displays today. We're going to talk about dot plots, stem and leaf plots, histograms, and box plots. Probably the two most common are box plots and histograms, so we will spend a little bit more time with those, but I still want you to be familiar with dot plots and stem and leaf plots, and so we're going to go ahead and work through a few examples of those as well. We're going to start with dot plots. So dot plots are a data display which uses dots placed over a number line to represent each unique observation. So to start off with, and we've got an example of a dot plot over here, we're just going to take a look at an example of one and how to read it before we make our own. So in this first example, Susanna is a casual nurse. She used a dot plot to keep track of the number of shifts she did each week for a number of weeks. So in this case, in this dot plot, what does each dot represent? It represents 1 week of work for Susanna. So 1 week of work. Okay. Uh, and so it doesn't represent, and I think the common misconception would be it's the number of shifts per worksheet weeks. Well, that's what these values down here represent. Each dot represents another week. So this would be 1 week where she worked 3 shifts. This would be a total of 5 weeks where she worked 4 shifts per week. So how many shifts per week occurred the most? We can figure that out pretty quickly. That would be right here. That would be 6 shifts. So it looks like most commonly she's working 6 shifts per week. So to make our own, we're going to do that with some heights of basketball players. So I've got those heights here for us. We're going to create a dot plot to display the data. So first off, we need to figure out how to label our axis here, our number line. We're going to be doing it in heights in inches. So if you wanted to go ahead and get your label in there, that is something that's very important. Then let's look at our numbers. It looks like our smallest number is 68. I believe the largest number I'm seeing is 84. So let's do this. Let's start at 68 and see if we can just count by 2. So that'll make it really easy. So 72, 4, 6, 8, 82, 84. Awesome. So it looks like we're going to be okay with that, which means that if we have an odd number, we'll just put it kind of halfway in between on this number line. Okay. So starting with 68, what I like to do once I put my dot there is to cross it off. That way I remember that I've put it on there. So then 70, another one at 70, and once you've cut on, you can probably go a little bit quicker than I am. In fact, if you wanted to fast forward to the end of it to check to see if you got it right, that would be another thing you can do. I'm trying to go as quickly as I can here, so we don't take too much of our time. But hopefully you get the idea of kind of what's going on. Dot plots are a very easy kind of data display to make. They are one, however, that isn't always the most useful when you're trying to read it. So that is one thing, kind of a drawback that you have. But with how easy it is to make, not necessarily the worst. Almost done here. 80, 83, 80, 71, and 70. Okay, I think that's all of them. So, not that we have to, but I always like to look to see, does it make sense what I'm looking at? And to me, I kind of notice there's some groupings. Like there's a group here, a group here, a group here, a group here, and then one kind of out here. And maybe for those familiar with basketball, it might kind of make sense why that is. For those that are not familiar with basketball, that's okay. But if you think about it, why would there maybe be 5 groups and they're based on height? If you're familiar with basketball, you probably already figured this out. But there are 5 positions in basketball. There's typically a point guard position, a shooting guard position, a small forward position, a power forward position, and a center. And oftentimes those are somewhat determined by the height. And I'm not sure if that's the case here, but it would kind of make sense based on the scenario that we were given, why those groups kind of might be there, which is something I always like to think about. All right, so next one, and this is a big one, histograms. So a histogram, first off, You might notice that over here, all caps and underline, I wrote that this is not a bar graph. And that's true. It is not a bar graph. So just get that idea out of your head. We're not going to be doing anything with bar graphs in this unit. We are going to be working with histograms. So let's talk about kind of what those are and how they compare a little bit to bar graphs. So a histogram is a data display that groups numerical data into bins and then uses the height of bars to represent frequency. So similar to a bar graph, however, bar graphs typically use what's called categorical or qualitative data. And with that, there's not usually this kind of running into each other. Typically in a bar graph, the bars are separated from one another. That's not true of a histogram. In a histogram, you'll notice that on this example that I've got for us over here, that each kind of piece of it runs directly into the next piece. And that's a characteristic that is true of a histogram, but not a bar graph. To show you an example of kind of how this works, so given the table below, we're going to create a histogram representing the number of calls received in a 2-week period. So notice that we've already got the labels here, which is kind of nice. So we've got frequency, we've got number of calls. Now here's the important part, is when you go to label this axis here, this x-axis, you're not going to put 0 to 3 and then 4 to 7. That's not how this works. If you notice, there's just a single value as you go across. In fact, a histogram is really on a number line. So what we need to do, we need to either decide to choose and use the left value or the right value of each of these intervals. And one probably makes more sense. It's the one that's probably easier to count by. I think we would all agree it's easier to count by 4s by going 0, 4, 8, 12, and 16 than it is 3, 7, 11, 15, and 19. So we're going to go ahead and label our axis like that. So 0, 4, 8, 12, 16, and even though we don't have 20, we do have everything 16 to 19. In other words, each of the bars we draw is going to include the left value, but not the right value. So when we draw a bar here between 0 and 4, that's everything from 0 up to 4, but not including 4. And if you remember, that has a frequency of 2, so then that would be a bar of height 2. The next one from 4 to 7, so up to 8, had a frequency of 5. So we'll draw another bar in there, up to 5. The next one had a frequency of 2. Okay, that one is. The next one had a frequency of 4. So here's that one. And then the last one had a frequency of 1. Okay, so that's histograms. Pretty straightforward. I think most of the stuff today should be pretty easy for you. One that might take a little bit of a refresher, you should have seen it before, but just to make sure it makes sense, is this box plot. So in a box plot, it's going to use what are called a box and whiskers, which is probably how you are more familiar with it, is as a box and whisker plot. We typically just call it a box plot. Above a number line to display what's called the 5-number summary. So the 5-number summary is going to be these values that I'm going to underline right here for you. I'll actually just kind of put a bracket around them. So these 5 values from minimum up to maximum are what are called your 5-number summary. So you've got the minimum, what's called quartile 1 or Q1, median, quartile 3 or Q3, and the maximum. Where the minimum and maximum should be pretty straightforward. The median is the middle value, and then quartile 1 is the median or the middle of the first half of the data. Quartile 3 is the median or the middle of your second half of the data. What's kind of nice is that those quartiles separate your data into some nice chunks. When you're graphing it up here, I'll kind of label it here for us. We've got our minimum and maximum, which go out on the whiskers. We've got Q1 and Q3, which are the ends of our box, and then the median is our middle. What's really kind of nice about the quartiles is that it breaks up your data very conveniently. It actually breaks it up to where each section is 25% of the data. Now, in addition to that, we also have another characteristic, which is called the interquartile range, or IQR. So, interquartile range, which should kind of make sense. What that's saying, inter being in between, quartiles being Q1 and Q3, and the range being from the largest to the smallest, so Q3 minus Q1. It represents the middle 50% of the data. In other words, it represents the box. Okay, so let's do some practice with finding those values as well as graphing. So we were given the following Boolean scores: 25, 39, 52, 75, 78, 91, 100, 108, 130, 150, and so on. Find the 5-number summary and create a box plot. So first thing, Q1 would it be, or minimum, let's do it first, is 25. That one's pretty easy to find. 220 is our maximum. Put that over here. And I guess another easy one to find is our range. Range is just your maximum value minus your minimum value. So 220 minus 25 is going to be 195. All right, let's find the median next. So median, I like to use the cross-off method, which is probably how you're familiar defining it as well. I'm just going to cross off values in pairs until we end up with a number in the middle. So I think I went too far. Should have been on 78. Here we go, 78 and 131. And it looks like our median is going to be right at 100. Now, here's kind of the tricky part about finding Q1 and Q3. I'm going to try to color code as best as possible. But for Q1, the first 50% of the data does not include 100. So when you're finding Q1 and Q3, the first half does not include the median, neither does the second half. But you can find those kind of the same way. So for Q1, I just cross off going the other direction to try to find the median. In this case, I get two numbers in the middle. And just as a reminder, when you have two numbers in the middle, you're just going to find the halfway point of those two numbers. The easy way to do that is to find the average. So take 52 plus 75 and then divide that number by 2. Tells us that 63.5 is going to be our first quartile value. We'll do the same thing for quartile 3. So now instead of looking at the first half, we're going to look at the second half of our data. And again, we're going to find that the same way. I'm just going to use cross-off method, this time between 150 and 168. That one's a little bit easier to do in my head, which is 159. And then finally, we've got our interquartile range, which is going to be the distance between Q1 and Q3. So if we take 159 minus 63.5, that should give us our interquartile range. So 159 minus 63.5 is 95.5. That would be our interquartile range. Okay, now as far as graphing goes, you only need 5 of those numbers to be able to graph, which is your 5-number summary, which is everything on that top line. So for minimum at 25, I'll go ahead and put a smaller kind of tick mark there. For 63.5, which would be about halfway in between 50 and 75, I'm going to put a slightly larger tick mark since that'll be part of our box. We had our median at 100, Q3 was at 159, and then our maximum was 220, so a little bit before 225. And then all we have left to do at that point is connect our box. So the middle 3 ticks become our box, and then we'll draw the whiskers, or the arms, however you want to think about it, out to those other 2 values. Now, I do want to also show you something else that can be kind of convenient, which is that you can actually use your calculator to help you find a lot of these values. To do that, there's this stat button, which is kind of in the middle of your calculator. If you hit that stat button, you're going to choose this first option, which allows you to edit values. Well, what you're going to do is you're going to put all the values from your bowling example into your graphing calculator. Now, if there's already stuff in it, like in list 1 here, I already have some values in there. To clear those out, if you just go up to where L1 is and then press clear, do not press delete, press clear, press enter, it'll clear out all those values for you. So let me type those in real quick and I'll show you how you can save a little bit of time doing all this by hand. So 25, 39, 52. We had 75 that came up twice. And then we had, I believe, 91 and 100. Okay, and then the second half was 108, and then 131, 131, 150, 168, 201, and 220. Okay. Once you've got all those typed in, first thing I would do is I would just go through and double check to make sure you got all the numbers typed in correctly, which I think I do. So I'm not going to double check it, but if we come up with different numbers, it's probably because I typed one of them in wrong. So to get these numbers, you're actually going to go back to the stat menu. You're going to go over to the second menu. So instead of edit, you're going to move over to calc, And you're going to choose this first option, which says 1var stats, which is an abbreviation for one variable statistics. Now, if yours comes up with a menu, then you'll just leave list as list 1, frequency list, you won't put anything, and then you'll hit calculate. If you don't have that show up, so if you don't have a menu, then you can just press enter and it'll give you these values anyways. Now, the first kind of 5 or 6 of these we're not going to talk so much about, but where it starts with min, that's kind of the most useful for us right now, which is that it tells us the minimum value for a data is 25. It also tells us that Q1 is at 63.5, which is what we came up with. And if we use the arrow keys to scroll down, it'll tell us the median was 100, that Q3 was 159, and that max was 220. Now the two it won't give to us are the range and interquartile range, but hey, if it'll give you all the rest of these values to do a little bit of subtraction, really isn't too hard. In fact, there is actually a way to graph these on your graphing calculator, but I think I'll save that for if you choose to take my stats class. That'll be something I can show you then. Not necessarily something that's all that important to show you right now. Okay, so that's box plots, very useful data displays. The last one to talk about is stem and leaf plots. So with stem and leaf plots, this uses all but the last digit of a number as the stem, and then the last digit becomes the leaf. To give you an example, if I was looking at the 26 and this leaf of 8, then 26 with 8 is really the number 268. To give you another example, maybe I'm looking at the 24 and this 5, then 24 with that bar 5 is really representing the number 245. So let's go ahead and make our own. We've got a set of data here. Tells us that the test scores of 12 students biology are listed below. We've got these values, create a stem and leaf plot to display the data. So we want to start from least to greatest again. I think the least number is 53. It's already got that first digit of 5. We only need to write that second digit of 3. And then 56 would be our next largest, so 3 and then 6. Okay, that should take care of the 50s. Let's look at 60s. We've got 64, so we'll put the 4 down. 65, so we'll put the 5 down. And then I think that's it for 60s. For 70s, we've got 73, 76, and 76, so a couple there. For 80s, we've got 82, 85, and 86, so 256. And then for 90s, we've got 94 and 92. Make sure you're going in order, so 92, 94. The other thing that's good to have is what's called a key, which basically does what we did up here and says that the number 5 bar 3 or 5 line 3 is really representing the number 53. Not super important, but a good thing to have when you're looking at a stem and leaf plot. All right, so let's do a little bit of practice with reading a stem and leaf plot. So example 8, the stem and leaf plot below shows the number of desserts that are ordered at a hotel over several randomly chosen days. How many days are in the sample? We can just count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like there were a total of 10 days. For what is the median number of desserts? You can find that actually by using the cross-off method. So to show you how that works, starting off with our lowest number would be 13, largest is 54, and the next is 14 and 53, and again we continue to cross off pairs of numbers until we end up with two numbers in the middle, which are 34 and 46. So if you want to find the median, just add those up, divide by 2. That ends up being 80 divided by 2, tells us that the median number of desserts is 40. To find the mean, don't forget what the mean is. I guess we haven't really talked a whole lot about the mean, but the mean, remember, is the same as the average. So if we're wanting to find the average for this set of data, we just need to add up all the numbers and divide by how many there are. So that would be 13 plus 14. Make sure you're adding up the actual numbers. Notice that I'm writing like 27, not just the 7. So it's very important when you're finding the mean that you use the full number for each of the values. So 33, 34, 46, 47, 52, 53, and 54. Once we've added those all up, we'll divide by how many there are, which we figured out in part A that there were 10 days in this sample. So that would tell us that the average was about 37.3. I guess we better put some labels on there. Both parts B and C would have been labeled as desserts. All right, that's all I've got for us in this second section of the notes. What we'll talk about in the next section is how we describe these data displays. So we've talked about how to collect the data. We've now looked at how to represent the data using graphs and data displays. And then so the next section, we'll talk about how we describe those data displays, how we get information from them, how we compare them, similarities, differences, all that sort of stuff. That being said, have a good rest of your day, guys, and I will talk to you next time.